All right, let's face it, guys. Sometimes physics can feel like a soup of equations. In our study of motion, these are just a sampling of some of the equations we might use to describe one-dimensional motion. Now, the danger, of course, is to have all of these equations and not really understand what they mean. We need to have an idea of what motion is actually being represented and not just plugging numbers into an equation. So, the superior way to do this will be in the form of a picture or a graphical way of representing motion. Number line can be used to talk about the location of an object. So suppose here I am, and I want to talk about where I am and how I'm moving. Well, the first thing I have to do is to define a location on the number line by which other numbers will be measured. So this special location is called the origin. It's the place of 0 position. So this number line represents the vector position of the object. And in this particular situation, I've placed my character in a positive position. Everything to the right of the origin is in a positive position, and everything to the left is in a negative position. So he looks a little sleepy here. Wake up, Philman. Put you here in this negative position. So if Philman begins here in the negative position and just stays in this location, well, that's kind of boring. That's no motion at all. But let's keep that in the back of our minds, just standing in that position. Well, suppose I get tired of staying in that location and decide to take a stroll to the positive side of life. And now here I am in a positive position, having moved from the negative to the positive. Now, we were able to just watch that motion happen, moving from the negative to the positive. What would that look like on a position versus time graph? This would give us a complete snapshot and a still kind of photo, if you will, of what this motion looks like. Now we're going to take our position time graph, and notice now x, our position, is on the vertical axis. We have time on the horizontal and position on the vertical. So this will represent the 0 position. This will represent everything down here, and this below 0 will be my negative positions, and everything above 0 will be my positive positions. So if I'm just going to stand in a negative position, I'm just going to stay here, then that means at all times on this graph, all of the times, I'm always going to be down here at the negative position. So that's not a very exciting graph. And if I wanted to represent somebody just hanging out in a negative position, it would look something like this, at all times in the negative position. On the other hand, if I were to choose to take my nap in the positive position, then my graph would look something like this. It'll be an object at rest in the positive position. So let's suppose that I decide to take a little trip and I decide to travel from the negative position to the positive. So here I am going for a stroll, beginning at the negative position. I want to end in the positive position, but time has to go by in order for me to do that. So sometime later, having begun at the negative position, I have now moved to the positive position. So overall, my motion on the graph is going to look something like this. Now, that was at a relatively slow rate. Suppose that instead of strolling from the negative position to the positive, I decide to run. Well, I should still end up going to the positive position, but it shouldn't take me nearly as much time to do so if I'm running. So I should be able to travel from the negative to the positive position in a shorter period of time. And as such, my graph will look something like this. So both of them, I have positive uphill slopes, representing the fact that my character is always traveling in the positive direction or towards the positive positions. Rotate this like this, headed in that direction. But the red slope is steeper than the green slope, showing that he's traveling faster in order to do so. So let's consider one more example that's maybe a little bit more complex. Suppose that I begin by sleeping at the origin. Sometime later, I begin to stroll and move in the positive direction. After a while, not content with strolling, I decide to prance in the positive direction. and then finally sprint in the positive direction. So the whole time I'm moving in the positive direction, but I've got 4 different types of motion: rest, walking, prancing, and running. And all of those should be able to be represented in one still snapshot on a position versus time graph. So let's think about what that might look like. All right, so we have a whole bunch of different times and then our positions. So if we go back to the initial time at t equals 0, I began at the origin at the 0 position. After a little while, I began to walk, so I'm headed in the positive direction towards my positive positions at a slow pace, and then sometime later continuing to move in the positive direction at a faster pace, and then finally at a dead sprint. So I see myself as time goes by headed in the positive direction, but this gradual change in motion can be represented by curvature on my position versus time graph. We see that the slope begins at 0, representing sitting at rest, and then gradually gains in steepness, still ending up in the positive direction, but doing so at an increasing rate. On the other hand, this green line might represent the same sort of motion in the positive direction, but this would be if I were to just travel at a steady rate in the positive direction. So what do you think? Can you do this yourself? Let's see.